Intelligent technologies for a sustainable energy future. This panel discussion is co-organized with KIOS. Please welcome Andreas Stavrou, Assistant Manager, EAC Transmission Substations Department, Rogiros Tapakis, Deputy Spokesman, Cyprus Transmission System Operator, Lenos Hadjidemetriou, Research Lecturer, KIOS Research and Innovation Center of Excellence. The discussion will be moderated by Markos Asprou. He's a Research Lecturer, KIOS Research and Innovation Center of Excellence. Gentlemen, welcome.
Ladies and gentlemen, good afternoon. First of all, allow me to thank the Cyprus Forum team that organized this conference, which actually provides the opportunity for a constructive dialogue, exchange of ideas and knowledge, and sharing in a topic of public interest. Now allow me at this stage to also thank our panelists here. I would like to thank for participating in this panel, for accepting the invitation, and for sharing their ideas and knowledge in a topic related to Cyprus' transition to a sustainable energy future. It is a great pleasure that we have in this panel Dr. Andreas Stavrou, Assistant Manager at the Transmission System Owner Department of the Electricity Authority of Cyprus. We have also with us Dr. Rogiros Tapakis, Market Engineer and Deputy Spokesman at the Cyprus Transmission System Operator. And last but not least, Dr. Lenos Hadjidemetriou, Research Lecturer at the KIOS Center of Excellence of the University of Cyprus. Dear colleagues, as you probably know, the energy sector is responsible for more than 75% of Europeans' greenhouse gas emissions. It's a major contributor to climate change as well as to severe environmental and health problems. Transforming the energy sector is very critical and is among the top priorities of Europe, which actually has set targets for reduced greenhouse gas emissions by 2013 by 55%. And the aim is to reach climate neutrality by 2015. The critical and digital transformation of the energy sector is at the heart of the European Green Deal and the United Nations Sustainable Development Plans. In this framework, Cyprus, as a member state of the European Union, has set its own target for reaching the goals and eventually achieve a climate-neutral economy. I will start the discussion with Dr. Tapakis, and I would like to share with us what are the targets of Cyprus regarding the penetration of renewable energy sources. And I would also like to hear your opinion about the challenges that the power system operator will face as it is envisioned that the high penetration of renewable energy sources will be in the power system in the future.
Thank you. Thank you for inviting me. As a major point of this discussion, we must concentrate on the fact that Cyprus is an isolated system, isolated electrical system, which means that there is no interconnection electrically to the European network. So what does this mean? It means that in our system, all demand for electricity should be satisfied by local generation and vice versa. All generation locally should be equal to the demand. And regarding this, we must distinguish energy from power. It's not always setting a target for a penetration of renewables in an annual term or in a daily term. We must also see every single minute, every single second of the day. in example yesterday, which was a sunny day of autumn, we had a daily penetration of renewables of approximately 17%, while the maximum penetration was 42%. What does this mean? We have a lot of renewable generation during midday hours and very minimum state during night hours and early morning hours. So, what is our challenge here? To answer you, our challenge for 2030 is to install 1,000 megawatts of photovoltaics. Currently, we have approximately 370. So we will almost triple existing photovoltaic penetration. And in addition to this, we will also have wind penetration, wind turbines. And as I said, we aim to reach 1,000 megawatts of photovoltaics. But last year, the average load was approximately 600 megawatts. So the actual question here is, who will use this generated energy from the photovoltaics, given that currently we have no storage and no interconnection? And this is the major challenge for the transmission system operator of Cyprus, how to control the not needed energy in order to maintain the stability of the system. And additionally to this, we must remember that conventional generation is a prerequisite for the system to maintain voltage and frequency and the ancillary services. So this is another challenge, how to control existing conventional and the new challenges for the renewable penetration. Another challenge is the topology of the electrical system. Traditionally, the flow of energy was from the generation to the consumption, from the transmission system to the distribution system through the medium voltage and the low voltage. Nowadays, the increased PV penetration, distributed generation, is at the consumption sites at the end of the system. And what we observe since 1-2 years in the past, there is negative flow of energy from the consumption sites, from the distribution system. It goes back to the transmission system, and then again back to the distribution system. And additionally, the quest for cheap photovoltaic land favors the development of photovoltaics at the end of the system at agricultural land, which is very cheap. But the existing development of the system those sites are very weak. They cannot support the new photovoltaic generation at the end of the system. So, in simple words, we need a full redesign of the transmission system in order to meet our targets for 2030 and go to a decarbonized system. And these are the major challenges for the transmission system operator, without forgetting storage technologies, demand-side response, and interconnection, which we assume that it will be the future of our system. And finally, last words, transmission system operator, another challenge for us is the upcoming electricity market. In mid-October, we will run a second dry run. It will take place and with the participation of the key players in order to find any trouble with the new management system and provide us significant information about the market. Thank you.
Thank you, Rogiros. It's really exciting that we are envisioned that we are going to triple the renewable energy sources, but at the same time, it's a bit scary since challenges are ahead of us, Andreas.
Yeah.
And it seems that the role of Electricity Authority of Cyprus, which is a key player in the energy industry sector, and also I think it will contribute significantly to the green transformation of the power system. It will have a key role to play. In what we hear about the challenges that we are going to face by triple the photovoltaics, let's say, and generally the penetration of renewable energy sources, how do you envision that these challenges can be overcome in the near future?
I'm glad with the way Rogiros put them on, because to each one of them, we need to give some answers. The main challenge is the congestion of the grid. We have, as Rogiros said earlier on, we have people investing or have licenses and they are ready to invest in places where the land is cheap. And unfortunately, in those places, the network is not strong enough to handle it. We used to produce energy in Vasilikos power station, in the Gelia power station. The backbone of the system is done in a way that all the power is going to come from Vasilikos and the Gelia to the center of load, which is the capital. Now we have investments towards mountainous areas, especially outside Nicosia in places on the road to the Troodos Mountains. There are thousands and thousands of applications for people that need to connect. People need to invest. But there the network is 66 kV. It's not even 132 kV. So what do we do? Okay, there are traditional ways. We need to find the traditional ways and the modern ways to solve the problem. It's not one-dimensional. The traditional way, we need to reduce the bottlenecks. Like the example I just said, we need to go into that place and do a strong backbone in order to carry the large amounts of energy that are going to produce in that place that nobody could even imagine 20 years ago that could be needed. On the other hand, we need to consider storage. We need to strategically place storage in transmission substations where we know that, for example, in an area that now is fully congested, there are no more places to install. If you install 50% of that capacity as a storage, then immediately you have another 100% of renewable energy to be installed in the substation. And this is the way ahead. We need storage, and we need also the market to pick up. Mm-hmm. The market needs incentives to invest in storage. It's not just the transmission system that needs to be addressed in this way. Okay, the other thing I want to say is that reconductoring is one, storage is the other thing, but we also have intelligent devices now. We have power electronic devices that can be used in a way to decongest and reroute power. We can go ahead and install these devices on our system. We don't need to install them in many places, but we know that there are certain cases where you have, during the day, a lot of renewable energy produced, and you have a lot of power to redirect. But in the night, you don't need to redirect anything. So you need power electronic devices to be installed. The disadvantage of this solution is that they are expensive. We still need a lot of money to install them, but in certain cases, we can prove that the solution is viable and is worth doing it. And the other thing I want to say a few words about is we need to engage people. Demand-side management is top priority of all the European fora. We know that people need to respond to the needs of the network by responding to market signals. So as long as not just the Electricity Authority of Cyprus department that deals with tariffs, but all the private companies that come up nowadays and they sell energy as retailers, they need to come up with tariffs that are related to how much is the energy cost for each half an hour. And people, when they see the signals of the market, I'm absolutely sure they are going to respond to it. Therefore, the idea here is to have the system doing its job, apply the ways that we need to discongest the grid, and then we need people to be engaged. There are a few other things, like in order for the system operators to know what to do for any minute, any time, any second on the network, they need visibility. And visibility is available now with ICT technology, with phase load measurement units. As you know, we had, together with KIOS, installed in many places in Cyprus, the phase load measurement units that allow full visibility, at least at the transmission level. We are able to see and assess the state of the system in order to respond very quickly. With this in mind, I think that we are very positive in seeing the network that can go ahead in a way that is going to be serving people and enable the renewable energy to be more installed. We are slightly behind with the storage. We need to go ahead with storage very quickly. That's what I would like to say.
Thank you, Andreas. Actually, very enlightening, let's say, aspects here. I will stick to what Andreas said about there are traditional ways and modern ways, Dr. Hadjidemetriou. And I think in the second aspect, modern ways, I think academia has a strong role to play here. And actually, I would like to ask you, how do you envision that academia can accelerate this green transition, even for Cyprus?
Actually, this is a very good point, Marco. I'm happy that you didn't ask me about challenges and solutions, because I think my colleagues cover absolutely perfect this topic. So, yes, actually, yes, it's a very. I strongly believe that academia has a significant role and must have a major role in this green, digital, and intelligent transition of the energy system. Of course, now the question is how we can do that. So I would say that let's say one effective way to do that, or at least what we are actually doing at the KIOS Center of Excellence towards to this direction, is to focus our activities in three main directions or axes. So the first is, we need to understand the problem as academia. Then we can perform high quality research. And then from the result of this research, we should involve as a third direction, we should be involving several innovation actions in order to transform this solution into, these methods into solutions. So now how we can understand the problems of the industry. This is a typical issue. We all know that there is a gap between industry and academia. So what we are actually trying to do at the KIOS Center of Excellence is to maintain a strong, direct, and long-term collaboration with all the key stakeholders of the energy sector in Cyprus. Of course, including the transmission system operator, the Electricity Authority of Cyprus, Cyprus Energy Regulatory Authority, and several SMEs that are active in this topic. And actually, through this effective collaboration, what we are able to do, we are able to understand the problems, the challenges, and also the needs of the industry, and then to move on to provide some tailor-made intelligent solution that will cope with these challenges in a way, let's say, to close the gap between industry and academia. So the first step is to understand the problem, and then if the academia or the research society understand the problem, then it's straightforward how to introduce and formulate new intelligent solutions and methodologies in order to enable this transition of the energy sector. And so these intelligent, let's say, methodologies, how we can develop them, we actually need to combine the expertise from the power and energy system with some theoretical tools on the other hand, and these tools are related to advanced analytics or monitoring techniques, control and optimization methods, or even artificial intelligence-based techniques. And so the result of the research now, what is it? It's just a methodology that can potentially contribute to the transition. The methodology itself can do nothing. So, however, the problem is how to transform this typical methodology that have been tested, let's say in a simulation environment or something, into an actual product or service or solution that can have a significant impact to this transition. And this, how we can do that? We can do it if we have joint action between academia and industry, and this action should be focused on innovation activities. And I think at this point it will be good maybe to, Andreas has already mentioned something, but I think there is some great examples, some success story in Cyprus where the academia and the industry has effectively collaborated in order to enable this transition, the intelligent transition as we were. And one example is, of course, the Empower and OneNet project. This is what Andreas have mentioned, where we have, we can see all the steps here that we have initially upgraded the measuring infrastructure of the EAC substation. And then we are, as KIOS, we are able to take this measurement and we are developing new methodologies, intelligent methodology to advance the monitoring or control capabilities of the power system. Now, what we have been able to do through this project is that we take these methodologies, we integrate them in a software platform that is going to be installed at the National Control Center in order to be used by the operators, the transmission and the distribution in some cases, to advance their management capabilities in order to be able to run the system under massive penetration of renewables. And just to conclude, another great example in this area, since my colleague mentioned the storage, I think too many times, but it is because it's so much important. Through another important activities in that direction is also the development of several pilot energy storage system through Wide Storage and Empower project, where we have an effective collaboration between the KIOS Center of Excellence and two SMEs, the Aeolian Dynamics and WiseWire. And in these pilots, what we have integrated sophisticated control optimization and forecasting techniques in order to enable the cost-effective operation of the battery storage system or different kind of storage system, and at the same time to provide supporting functionalities to the power grid of Cyprus to allow to maximize actually the penetration of renewables into the system. So my final remark is that yes, it's very important, the role of academia, and we need to close the gap with industry in order to fight this challenge together.
And Andreas, I will take the opportunity. Lenos mentioned data. And you also mentioned we need to know that how the customers need to be categorized in different tariffs.
Yeah.
So as far as I know, in Cyprus, we have only two bi-monthly, let's say, data for our consumption. Do you think that we need to invest in smart metering or advanced metering infrastructure?
We are already late. Smart metering is a key to the opening of the market. Okay, Electricity Authority of Cyprus, although it's not our department, I know that they just managed to sign a new contract for 400,000 new smart meters. Smart meters is a key mainly for the private investors to know what they're doing, but also for the homeowners, for the business owners, to understand what is happening with their consumption, their own consumption. People need to understand how this is happening. And if they have data, and I'm absolutely sure they are going to have a lot of youngsters from KIOS tomorrow coming up with different applications that are going to say to people, install this application on your phone, and you are going to see how you consume the energy minute by minute. Yeah. This is essential for people to understand how the energy is stored. And another thing that I want to say on these things, positive energy districts is something that at the European level is promoted, because we are going to have small clusters, communities of energy that are going to be positive. They are going to manage their own energy, and people that envision how this is going to happen, they see districts and local communities to be the key in managing their own energy. And to do that, they need, of course, meters, they need the data to do it.
Exactly, and on top of that, we need intelligent technologies.
Sure.
Yeah. As a Rogiros, something that I would like to also discuss, let's say briefly in terms of time. We didn't discuss electric mobility.
Yes.
And electrification of transportation, actually. And I will go to the electric vehicles at the, let's say, distribution level. What do you think, how will change the type of, let's say, load curve? How will change, let's say, the behavior of also the person operator if in 2030 or in 2050, 50% of our vehicles will be electric?
Electrification of mobility is another challenge, a major challenge. We are also in this section a little late in Cyprus, but the aim for 30 and 40 is very high. It will totally change the demand curve of the system. If we go with a simple approach, people will go to their houses in the night, in the evening, and they charge their cars. So this will be another challenge. It will have negative results on the system. But through the signals of the market, through the supplier tariffs, they may help the system, they may help to address these new challenges. If there are charging stations or a provision to charge cars, vehicles in mid-hours and during high PV penetration, high renewable penetration, then this will help the system. It will be something between storage and demand-side response. It has both, this has both the benefits, also some negatives, but control and the participation of people will be the key for the transition to electric mobility.
I think smart charging is
Smart charging is
Yes,
key
yes,
here.
agree.
smart charging is the key here to manage the curves and also facilitate the services to the network. You get from the battery of the car, you control voltages, frequency, everything, the services that the TSO needs.
We have vehicle to grid.
Exactly.
It's what we need, and it's a challenge.
Lenos, we have some seconds. I would
I
like
will
to hear, because we're talking about green and digital transformation, but digital also poses several challenges, and regarding the security of the grid. Where are we in this aspect?
Okay,
in
this is a different aspect, but we don't have to ignore it. So all these technologies that Andreas and Rogiros mentioned, so smart meters, intelligent inverters, storage, EV charging, if we cannot communicate with all these devices, we cannot do nothing. So all the intelligent, digital grid transition cannot be achieved. So yes, but communication with millions of devices at the end user, at the end of without the existing network. This creates, of course, security threats. An attacker can introduce to the network to intermediate this communication, let's say, and this will create significant threats. And these threats can be, someone can store energy, let's say, but someone can cause cascading blackouts, failures into the system. So we need two things. One, security by design, I would say, but this is not enough. So if we introduce a new technology and put a lot of security measures, we can secure the smart grid framework. However, there is traditional equipment, there is existing equipment in the grid that will remain in the grid for, I don't know, 50 more years. So we need to, just to final remark, we just need to introduce also some intelligent intrusion detection system to recognize these attacks and isolate them before allowing them to have an impact, a negative impact on the system.
Thank you very much. I would like to conclude here. Thank you all for your presence. Thank you, dear panelists and colleagues, for your presence.
Thank you very much. I think you need to invent an intelligent cutter to cut people off when they're talking as well. Thank you very much.